A good afternoon to all the participants to the next session. I hope you're enjoying LRVS so far. With me today, we are very honored to have Ms. Namrata Mohanty, PhD and a research scholar at the IIT Kanpur for Subir Chowdhury, School of Quality and Reliability. She is very passionate about sharing her knowledge with us, and she will be speaking to us about the topic Beyond the Road, a holistic approach to reliability and a safety assessment of electric vehicles. So, as we're all in the lubricant industry, this is a very important topic to us, and I'm really excited to hear what she has to say. This is a topic of very personal interest to me as well. So, I will allow you to share the screen, and then you should be able to share your screen, Namrata. So please, without further ado, take it away. Thank you.
Please confirm if my slides are visible.
Yes, they are visible. I can see them.
But I cannot see the cursor.
Oh, we can see the cursor. Oh, it's white against white. While Namrati is bringing up the presentation, the audiences can ask questions during the presentation in the chat or in the questions box. And if there's still time left at the end of the session, we will take some time to see that. I can see your slides now, Ms. Namrata.
Okay, but I cannot move to the next slide. How can I move to the next slide?
Can you try to click the right arrow? That should usually do the trick. Yeah.
Now I can see. Yeah.
Okay. Great.
Okay.
Great. Thank you.
Okay. Thank you. So, ladies and gentlemen, a warm welcome to all of you today. It's my honor to discuss a topic of great significance and relevance in today's fast evolving world, that is a beyond the road, a holistic approach to reliability and safety assessment of electric vehicles. So these are the contents which I will follow up. First, with the barriers for adoption of electric vehicles, then some importance of reliability and safety assessment for the electric vehicles, the battery as the most critical part and its reliability and safety assessments, some of the reliability issues and safety issues related to the electric vehicles. Then our topic are the holistic approach to the reliability and safety assessments, following some safety standards and testing, and two case studies related to it. So indeed, the adoption of electric vehicles is gaining momentum worldwide. However, several barriers continue to impede their widespread acceptance. And among these barriers, these technological barriers are limited to significant errors, such as the performance, range, and durability in terms of reliability and battery safety. So, reliability and safety assessments, it plays a vital role in evaluating and addressing unique challenges which are posed by the electric vehicle technologies. These assessments provides critical insights into the performance, durability, and safety of the electric components and systems. By following a holistic approach to the reliability and safety assessments, the manufacturers can enhance the consumer confidence and maintain a positive industry reputation. So, in this presentation, we will delve into the importance of this holistic approach to reliability and safety assessment for the electric vehicle application, along with some compelling case studies which showcases the practical application of such assessment. So, the battery reliability and safety assessment of electric vehicles. We know that the battery is the most important part of the electric vehicle, which consists of 40% of the cost. Among all these batteries which are currently in use, lithium ion batteries are proven to be the best part in the present use. So, for assessing the reliability and safety of the electric vehicle's battery, which is very crucial for ensuring overall performance, durability, safety of the electric vehicles. The battery reliability and safety assessments it involves the comprehensive evaluations, testings, and analysis of the battery systems to mitigate potential risks and enhance overall performance. So for battery reliability assessment, there is cycle life testing, which is involving the battery which are subjected to repeated charge and discharge cycles to evaluate their longevity and performance over time. This test helps to determine what is the expected lifespan of the battery and identifies if there is any premature degradation issues which is related to it. Then the aging and degradation analysis which is which is analyzing what is the pattern of the aging and degradation of the battery cells, which helps to predict what is the remaining useful life of the battery and enables what is the proactive maintenance and replacement strategies. There are certain techniques such as impedance spectroscopy and capacity feed analysis which are employed to monitor what is the battery health and assess the degradation rates. Then the third part is the accelerated life testing, which is simulating the real world conditions but at accelerated rates to evaluate the battery performance and reliability over extended period. By subjecting such batteries over such extreme temperatures or higher charge or discharge rates or demanding any operational conditions, we can identify what are the potential failure modes and we can address them. So coming to the battery safety part, there is abuse testing, which involves subjecting the battery cells to extreme conditions such as overcharging, short circuits, mechanical abuse to evaluate and respond the safety features. This testing helps to identify what is the potential safety risks and assess the battery ability to withstand the abuse without compromising the safety. Then the environmental testing, which simulates various environmental conditions, including temperature extremes or humidity or vibration or shocks. It ensures the battery, which can safely operate in different operational conditions encountered during the uses of the electric vehicles without compromising the performance or safety. The final part is the electrical safety evaluation, which focuses on addressing the battery's electrical characteristics to ensure safe operation. It includes like evaluating insulation resistance, leakage currents, and protection circuit for avoiding the safety hazards. There are certain reliability issues and safety issues which are coming into the point of contact. Some of the reliability issues are the capacity loss. That is, over the time, the battery's capacity to store the energy may degrade, which is resulting in reducing the driving range and performance. So capacity loss can be caused by various factors, which includes high operating temperature, cycling, or even calendar aging. The thermal management is in terms of thermal runaway, which is a catastrophic failure of the battery, which is potentially resulting in form of fire or explosion in the vehicle. The electrical issues like short circuit, cell imbalance can result in the reduced performance or even the battery failure in some cases. Environmental factors are when the batteries are exposed to a range of environmental factors such as temperature extremes or moisture, which directly affects the performance and reliability of the battery over time. Manufacturing defects are during the assembly or production of the production stage, which is directly affecting the battery's health. And age-related degradation is the reliability of the battery, which is affected by the degradation, which can cause a decline in the battery performance and capacity over time. Coming to the safety issues, there are four types of issues like electrical safety, which is the electric vehicles use a high voltage electrical systems, which can pose a safety risk if not handled properly. So this is the electrical safety part. Fire and safety means the electric vehicles, they contain a large amount of energy which is stored in the batteries, which can pose a risk which is related to fire or thermal runaway, which I already mentioned if not managed properly. Then the crash safety means the electric vehicles must meet the same safety standards as the conventional IC engines, including the crash worthiness, the protection, or any kind of pedestrian protections. And finally, the cyber security, as the electric vehicles are increasingly connected and becoming autonomous, there is growing concern of the cyber security and the data transfer, which is also needed to be pointed out. Coming to the holistic approach to reliability and safety assessment, it is essential for the comprehensive evaluation and optimization of the electric vehicles, components, as well as systems. This approach integrates the hardware and software assessment and implementing the multi-domain simulations and testings, incorporating the reliability modeling and prediction techniques, and incorporating the risk analysis and mitigating the strategies. So for the hardware and software assessment, this hardware includes the conducting of rigorous testing and analyzing what are the failure modes and identifying the areas for the improvement. The software assessment focuses on the software functionality of the embedded systems, including what are the control algorithms, what are the firmwares, and cybersecurity measures. It also involves evaluating the software reliability and robustness, which is crucial for ensuring safe and efficient operation of the electric vehicles. For the multi-domain simulations and testing, it enables the evaluation of EV performance and safety under various operating conditions. These simulations they combine the electrical, thermal, mechanical, and control system models to analyze and interact between different subsystems. This also it enables the identification of the potential failure modes and validates the performance of the components as well as the systems. Coming to the reliability modeling and prediction techniques, the reliability modeling encompasses the statistical and predictive modeling techniques to estimate the reliability and remaining useful life of the electric vehicle components. It involves analyzing what are the historical data, conducting accelerated life testing, and developing models to forecast failure rates and aging patterns. There are certain predictive maintenance strategies which can be developed based on reliability predictions, enabling the proactive maintenance and minimizing the downtime. And finally, the risk analysis and mitigation techniques, which means the risk analysis, it involves identifying what are the potential hazards and assessing their likelihood and consequences. This involves evaluating the risks which are associated with the battery fires or electrical system failures, the charging infrastructure compatibility issues, and safety critical systems. So, by adopting a holistic approach to reliability and safety assessments, the manufacturers can proactively identify and address what are the potential issues, optimize the performance and longevity, and enhances the continuous improvement of the electric vehicle technologies and drives a sustainable and reliable growth of the electric vehicle industry. So for that, there are certain safety standards and testings. So safety standards and testing, it plays a crucial role in ensuring the reliability and safety of the electric vehicles. So there are certain types of testings which are coming into contact for the reliability and safety part. The first is the crash worthiness testing. These type of tests evaluate the structural integrity and occupant protection measures to meet minimum that is safety requirements. Some of the electrical safety testings includes assessing the insulation integrity, the electrical grounding, and protection against getting the electrical shock hazards. The battery safety testing means including various thermal stability and performance under extreme conditions and resistance to mechanical type of stresses. Mechanical or the functional safety testing, it focuses on ensuring vehicle systems, which is either mechanical control or the software system control and perform as intended. Then finally, continuous monitoring means there is a necessity to identify what are the emerging safety risks and identify what are the potential risks and incorporate them to prevent the real world accidents. Environmental testing also includes the exposure to the extreme temperature, humidity, and vibration, and also the corrosion. So by adhering to all these safety standards and conducting the comprehensive testing, the manufacturers can effectively improve the reliability and safety of the electric vehicles. So we will go for the case study one. So first is the problem is the battery degradation and thermal runaway. So we know that the electric vehicle batteries are vital components that directly impact the reliability and safety of the electric vehicles. So in this study, we will focus on the problem of battery degradation, which is leading to a potential safety issue such as thermal runaway. So, over time, the electric vehicles can experience degradation due to several factors, such as cycling, temperature, aging, and continuous charging and discharging cycles. It leads to capacity loss, which is thereby reducing the range and performance of the electric vehicles. So the battery degradation and thermal runaway, these are connected. The battery degradation can increase the risk of thermal runaway, which is a hazardous condition where the battery temperature it rises uncontrollably, leading to fire and explosion. So for that, for the assessment and analysis, there are certain statistical analysis which is taking into account the battery performance data, which can provide insights into the degradation patterns and identify the potential safety risks. So by monitoring these health parameters such as temperature, voltage, and internal resistance, which can be helpful in detecting the signs of degradation and potential safety hazards. There are also certain simulation-based thermal analysis which can access the temperature distribution within the battery pack, thereby identifying what are the hotspots and evaluate the effectiveness of the cooling systems. So coming to the prediction and the modeling part, the prediction models, these can estimate the battery degradation and remaining useful life by allowing the proactive maintenance and replacement strategies. The accelerated live testing and that can be conducted to validate and refine what are the degradation models, ensuring their accuracy in the real world conditions. The reliability prediction techniques such as variable analysis can estimate what are the failure modes and failure rates and identify what are the potential failure modes which are associated with this battery degradation. So certain solutions are improvements are needed for it. So this can be design improvement, such as which can we can enhance the thermal management systems, which can be implemented to regulate the battery temperature and thermal safety. Thermal runaway we can prevent it. We can also bring the advanced battery management systems, which can incorporate algorithms to optimize the charging and discharging profiles, reducing the stress on the battery and thereby slowing the degradation process. Certain quality control processes also can, like during the battery manufacturing, such as improved cell assembly process and rigorous testing, can mitigate the risk of certain manufacturing defects. And lastly, like adhering some safety standards, there are certain safety standards which are present in the industry, and incorporating these safety features like thermal monitoring, the thermal fuses, the cell level protection mechanisms, it can thereby enhance the battery safety and surely it can prevent the thermal runaway accidents. So by addressing these battery reliability and safety problems through comprehensive assessment analysis and prediction and monitoring, along with certain solutions, the electric vehicle manufacturers can enhance overall performance, reliability, and safety of the electric vehicles by building confidence in the consumers and promoting their widespread adoption. To understand more, we can go for a second case study, which is addressing the problem of charging pattern optimization and thermal management of the reliability and safety. So, the charging pattern and thermal management of the electric vehicles are crucial factors that impact both reliability and safety. In this case study, we will explore the challenges which are associated with the charging patterns and the thermal management and their significance in ensuring the battery reliability and safety. So first is the charging pattern optimization. This is the charging pattern. It like determines how and when the battery should be charged. The improper charging patterns can lead to accelerated battery degradation, reduced charging capacity, and compromised reliability. So the charging patterns considers factors such as what is the charge rate or depth of discharge or balance of the cells, which maximize the battery life as well as the performance. The second part is the thermal management. Like effective thermal management it is very essential for maintaining safe operation of the temperature and preventing thermal runaway in the batteries. So high temperatures can accelerate the battery degradation and pose safety risks. So proper cooling systems, including active and thermal insulation cooling pattern, are required to and are critical to regulate this battery temperature inside the vehicle and ensure optimal performance safety. Then the assessment and analysis part, that is analyzing the charging patterns and historical data, which can provide insights into the impact of different charging strategies on the battery health and reliability. So this includes monitoring of the battery temperature during the charging cycles and real-time thermal management system feedback, which enables continuous evaluation and adjustments. For the solutions and improvements part, the optimizing charging algorithms and implementing smart charging systems can ensure balanced charging, reduce stress on battery, and extend its lifetime. There is a need of intelligent charging infrastructures with communication protocols that enable coordination between the electric vehicle as well as the charging station, optimizing charging patterns for the reliability and safety. Then comes the compliance and safety measures, like implementing safety features such as temperature monitoring, thermal fuses, and protection circuits. This adds an extra layer of protection against thermal related risk. And finally, user education and guidelines, like providing the guidelines and educational materials to the electric vehicle owners like us about the optimal charging practices and the importance of the thermal management posters, which is responsible for the charging habits and which can thereby enhance the reliability and safety of the vehicle. So, in conclusion, today I stand before you to conclude our discussion on the holistic approach for the reliability and safety assessment of the electric vehicles. Throughout our exploration, we have seen the importance of adopting a comprehensive perspective of in evaluating the reliability and safety of these vehicles. The significance of the holistic approach lies in the ability to integrate various dimensions, including technical, environmental, social, and economical factors. It enables us to examine the electric vehicle reliability and safety from a broad perspective, taking into account the entire life cycle of these vehicles. So, like we have already seen that this approach requires us to conduct a systematic risk analysis, which is identifying what are the potential hazards and assessing what is the likelihood of and the consequences. So by doing so, we can develop a robust testing and validation protocols to ensure the reliability and safety of the electric vehicles in various operating conditions. Even the standards, with what we state, the standards and regulations, these also play a crucial role in the holistic approach by establishing what is the clear guidelines that govern the design, manufacturing, and operation of the electric vehicles is very essential. However, I think that the holistic approach doesn't stop here. It requires continuous monitoring and maintenance, which are used to detect and address what is the potential issues throughout the life cycle of the vehicles. It requires the regular inspection, software updates, and proactive maintenance practices to keep these vehicles running smoothly and safely. So I think, in conclusion, a holistic approach for the reliability and safety of the electric vehicles is not just an option, it is a necessity. By considering all the relevant factors, such as we can say the safety part, the reliability part, it will bring confidence to this technology. So let us remember that our ultimate goal is not only to revolutionize the transportation, but also create a sustainable future. Electric vehicles are a crucial part of this vision. So, by adopting a holistic approach, we can ensure the reliability, safety, and long term viability. So, together, let us embrace this a comprehensive perspective, collaborate across various sectors, and strive to make electric vehicles a cornerstone of a cleaner, safer, and more sustainable transportation future. So these are my contact details. You can reach me out for any queries in future. As a manufacturing and reliability engineer, I will be happy to attend all your queries on time. Thank you so much.
Thank you very much, Ms. Namrata. Mohanty, it was great to have you here and to talk about this. It was really good to see this evolution. I think a very necessary evolution in the industry of electric vehicles. I'm checking the chat. There has been no questions from the audience, so I would like to ask for the remaining 5 minutes that we have a question to you. From your viewpoint, when you look at various OEMs, if we take a look at internal combustion engines, we see a narrowing of the differential in terms of quality and safety. So that means the OEMs naturally grow towards each other over time. How do you see this landscape in the environment of electrical cars? Is there still a much bigger differential between different OEMs? And can you give us a few words on that?
Yeah, sure. Like in conventional vehicles, we are not focusing more on the battery part, but in case of electric vehicles, we say that the battery is the most critical part. It is in normal cell phones we are using like one or two cells, but in case of vehicles they can be 4,000 to 5,000 cells inside the battery. So more number of cells can lead to more number of failures. So that's a point where we should be focused for it. Like we should pay more attention. Like what is the two main aspects such as reliability as well as safety. We are seeing like various accidents, fire accidents, which are growing maybe in Tesla or any type of vehicles, like because of this temperature climate changes, like there is fire accident. So all this is happening because of the battery only. Like the battery part is like which is not uh, a bigger concern in case of the conventional IC engine or OEM part. So by following all these techniques, the manufacturers can definitely they can take into consideration. They can make focus on this battery part from the initial stage, from the assembly or production stage to the final like delivery part. So by this we can look into it.
Great. Thank you so much. How do you see it with different countries then? So, for example, I can imagine that Europe would have different rules from the US, and then Asia will have a set of different rules per country. How is that landscape evolving?
Yeah. Like there are two types of region, that what is hot region type and cold region type. Both are affecting the battery health, I can say. In case of hot region type, we can see that in some cases the vehicles are burning out because when they are exposed to sun, the battery, because of battery, the vehicle fire is coming into contact. And in some cases, in also in cold region type countries, we can also see some cases of related to it like the battery fires, but most of the cases are related to the sudden decrease in the health. We are also like we are human, we have a life of like 60 to 70 or so. So like in case of this electric vehicle, the battery is also having certain type of health. They are giving a warranty of 8 to 10 years, but with this temperature extremes, like these all these countries will like different regions, these are directly affecting this health of the battery. In case of the like in place of 8 to 10 years, which is the warranty which is giving, the battery is degraded to maybe we can say 3 to 5 years it is degraded. So the customers are like they are affected from this type of studies. So there should be a like we should pay more attention to it and proper study with respect to these regions, like what is going on, this should be taken into consideration.
Yeah, absolutely. I agree. Very nice. So, in terms of innovation, do you have any view of pending innovations that might greatly affect the performance in the areas you laid out? Or do you think maybe there are certain innovations that you think are necessary to improve? Can you give us a few words on that as a closure?
Yeah, yeah. Like I've always said that what is taking place, like battery is most heated and it is taking place into the fire. So there is a particular all the vehicles have certain battery thermal management systems. So we can improve these thermal management systems in terms of like in heat region, we can go for advanced cooling techniques which should be present inside the battery. And in case of cold temperature, certain insulation techniques which should be there so that we can maintain the temperature. Like in case of lithium-ion battery, the optimal temperature of the battery should remain in 15 to 30 degrees Celsius. It is like it is stated, but to maintain this temperature, there should be certain additional features like the additional devices which should be present inside the battery to maintain the temperature. So that innovations, I think, it should be needed in future to to maintain the safety of the vehicles and safety of the as well as the passengers who are driving the vehicle.
Perfect, thank you. So thermal management is an important thing as well.
Yeah. Yes.
Great. Okay, we've run out of time. Very interesting, fantastic session. It was my great honor and pleasure to moderate you.
Thank you so much. Thank you for giving me a chance to present.
Most welcome. Thank you for your time. And thanks to all the attendees to the session, and hope you enjoy the rest of LRVS. Thank you very much, everybody. Take care.
Thank you. Thank you all. Good day.
Thank you. Good day.